Hello class, and today we plan to go over the questions on section 3.3, truth tables. Yeah, my plan is to go over 3.3 and 3.4. And we will have a homework today, all right? Let me show you, what homework. And in the worksheet, you go to worksheets. Do you see the number 3, this one? Yeah, it says number 3, but we are going to change that to number 2. Your download will shortly start it. If it doesn't download, okay. So the second assignment for the essential class is this worksheet. All right, is this worksheet. Yeah, I'm going to change that to assignment 2, not assignment 3. This is assignment 2. All right, let me know that you hear me about the second assignment for essential class. Worksheet number 2, truth tables. Yeah, not a lot, just 1, 2, 3, 4. 4 questions. Yeah, please respond to me and let me know you. Okay, thank you, Lauren. What is the due date? Yeah, in a week, within a week. Earlier the better. Yeah. And what about other classmates? And Natalia, thank you. Thank you, Carly. What about, okay. Layan, thank you. 1, 2, 3, 4. One more. Oh, only 4. Why did I see? Oh, okay. So who is missing? Who is absent here? Aiden, right? Okay. All right, so let's start truth table practice from the first one. Truth value. Every statement has a truth value because a statement refers to an English sentence which is either true or false, not both simultaneously. If the statement is true, the truth value of the statement is T. T represents true. If the statement is false, then the truth value of the statement is F. F represents false. Okay, so the negation of P has opposite truth value from P. For example, if P represents the statement that London is the capital of England, then not P would represent the statement that London is not the capital of London. So if P is true, then not P would be false. Okay? Yeah. P and not P always have the opposite truth values. Yeah. If we place the negation in front of a statement, then we change the truth value from false to true or from true to false. Determine whether the following statement true or false. If the statement is false, make the necessary change to produce a true statement. The statement here, if one component statement in a conjunction is false, then the conjunction is false. It is correct. Yeah, let me show you what is talking about. So earlier we talked about the negation, right? Conjunction. Let's say P and Q are two simple statements. If we have this symbol in between of the two statements, we have a compound statement. And this compound statement is called a conjunction. Is this about conjunction? Oh yeah, about conjunction. So this is conjunction. So if you are taking notes, please write down this sentence. For a conjunction to be true, both of the two component statements must be true. Let me repeat it. For a conjunction to be true, both of the two component statements must be true. What is component statement? This is one component, this is another component. Yeah, two components with the chiral notation symbol in between. That gives us a conjunction of the two components. Yeah, again, the sentence, please write it down. For a conjunction to be true, both of the two component statements must be true. In other words, for P and Q to be true, both P and Q must be true. Think about for this compound statement, for this conjunction to be true, the conjunction means P and Q. Of course, you have to make both, you require both statements, both component statements to be true in order for the and to be true. Does that make any sense? In fact, there's only one case in which a conjunction is true. That is when both the two component statements be true. Yeah, let me know if you have any questions about the conclusion here. Very, very important. You need to memorize, understand and memorize this rule. Yeah, you can see that as a rule. Any questions? For a conjunction to be true, both of the two component statements must be true. Yeah, you should have this in your note. Yeah, even just at least even just one piece, one component is false, the conjunction is false. Yeah, when P is false, Q is true, the conjunction is false. When P is true, Q is false, conjunction is false. When P and Q are false, of course, the conjunction is false. There's only one case in which we have the conjunction is true. That is when both P and Q are true. Any questions? Any questions? No? All clear. Perfect. Thank you, Lauren. Yeah. Okay, so just remember that one sentence. That should be enough. Okay. Yeah. And now let's read the sentence. This statement again. If one component statement in a conjunction is false, then the conjunction is false. So true or false? This is true. Yeah, we choose B. The statement is true because a conjunction is true only when both component statements are true. Yeah, that's actually the same thing, same with what I just wrote here, right? Yeah, maybe the wording is a little bit different, but means the same thing. So that is for conjunction, very basic, super, super important and basic. Let Q represent the following statement. Q is 3 times 4 equals 12. Is a true statement, right? Yeah. Determine the truth value for the statement, not Q. What do you think? Remember, the negation always has the opposite value. When Q is true, yes, Q is true because 3 times 4 is 12. Then not Q. The negation of Q would be false. That's very straightforward. Here we have two simple statements. P is 3 plus 5 equals 8 is true. Q is 10 times 9 equals 180. So Q is false, right? Yeah, so on your scratch paper, you need to write P is true, Q is false. Then what's the truth value for this conjunction? Yeah, P and Q. Remember, in order for the conjunction to be true, both component has to be true, right? Both component statements have to be true. But Q is false, so the conjunction is false. It's not true. In order for the conjunction to be true, both P and Q have to be true. But in our case, P is true, Q is false. So P and Q is false. All right, P and Q is false. Number 5. P is 2 plus 3 equals 4. That's false. Q is 6 times 5 equals 30. That is true. We need to determine the truth value for the statement, not P and Q. Okay, so here, the conjunction has 2 component statements. The first component is not P. The first component is not P. I'm sorry. The first component, is not P. Okay, the first component is the negation of P. Second component is Q. The truth value of this conjunction depends on the truth values of the 2 component statements. Let's look at the value of not P. This first component. P is false, so the negation of P is true. So the first component of this conjunction is true. And the second component of the conjunction is also true. That makes this conjunction true because both of the 2 components are true. As you can see, the 2 component statements not necessarily always be simple statements. P is simple. Actually, not P is always also simple, but sometimes it's more complicated than that. Make sure you find out the truth values for both components, and based on that to determine the truth value of the conjunction. As you can see, those questions, to solve those questions, all we need to know is this sentence, right? Any questions? 1, 2, 3. Next. Number 6. P is 2 plus 5 equals 7. P is true. Q is 6 times 9 equals 108. No, that's not true. That's false. 6 times 9 is 54. So P is true, Q is false. So this one is very similar with earlier. This is a conjunction because this notation, right? This symbol, the caret symbol. This is a conjunction. The first component is Q. Q is false. Since there's one component is false, so the conjunction definitely is false. Because for this conjunction to be true, both components have to be true. And you know what? We don't have to consider not Q. We only need to know they are not both true. Q is false. As you can see, Q is false. Q is false. It doesn't matter if the other component true or false. Doesn't matter. The conjunction is false for sure. All right. When you see at least one component is false, the conjunction is false. Is that clear? Any questions? 1, 2, 3. Number 7. Construct a truth table for the given statement. This is a truth table. Our target statement is the given compound statement, not P. The negation of P. Not P. So we have to see what's the values for not P as well. So let's see. Remember, not P and P have opposite values. So when P is T, now P is false. When P is false, now P is true. You see that? Okay, so now let's look at the column 3. Column 3 is the negation of column 2. So column 3 should have opposite values of column 2. So when not P is false, the negation of that is true. When not P is true, the negation of that is false. Yeah, so as you can see, negation of P, not P, go back P, right? Yeah, in fact, not P is actually just the P. Go back. Because P and not P are negation of each other. All right, any question about this truth table? Yes, since the this compound statement, this statement only involves one simple statement, P. So the truth table, the leftmost column would be P. And P only has two possible truth values, either T or F. So we have two cases here. Any questions? Okay, next. Complete the truth table for the given statement by filling in the required columns. So the target compound statement is not P and Q, is a conjunction. First component is not P, second component is Q. Yeah, so we are going to complete a table. Yeah, since this compound statement contains two simple statements, P and Q, the first two columns, they don't have a vertical line here, and actually it's supposed to have vertical line. The first two columns should be P and Q. The first case would be when both P and Q are true. Yeah, so I'll explain that after we finish the table. Yeah, so P is T, then not P is F. And the last column is the conjunction of not P and Q. Yeah, so the two columns preceding the final column, those two columns are the two components of the conjunction in the last column. So for this conjunction to be true, both of them have to be true, but that doesn't happen, right? It's not the case. So this conjunction is false. Even just the one piece, one component is false, then the conjunction is false. And you continue. When P is T, not P is false. When both components are false, of course, the conjunction is false. Right? So far, so good? Okay. When P is false, not P is true. And in this case, component Q is true. Component not P is true. That makes the conjunction true. Yeah, that's the case. The conjunction is true because both of the two components are true. When P is F, not P is T. And the conjunction is false. Why the conjunction is false? Because one component is false. Yeah, it cannot be true. In order to be true, both components have to be true. So, and that's it. You see that? Okay, so we do not rush to leave here yet. So this is the structure of a compound statement, truth table for a compound statement. When a compound statement involves two simple statements, P and Q, then the first two columns always be P and Q. And P has two possible values, either T or F. Q also have two possible values, either T or F. So 2 times 2 is 4. That's how do we have the 4 cases. In my video, I hope you guys watched my video, but I look at the statistics, the usage, nobody watch it. I feel very sad because I spend a lot of time every day. I make videos for the based on the syllabus, and turns out nobody watch it. So the first case is when P and Q both true. Second case, P is true, Q is false. Third case, P is false, Q is true. The last case is when both of them are false. Always like that, all right? Yeah, always like that. When the compound statement involves two simple statements, the first two columns in the table always look like that with the four cases, and you should keep the order as well. T, 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 F, F, T, F, F. Next question, number 9. Complete the table. So the target compound statement is not Q or P. Is it disjunction? Okay, let me explain. Disjunction. Disjunction is this right side up V, right? Yeah. If we connect, we use that symbol to connect the two component statements, let's say P and Q, then we have a disjunction. It is called a P or Q, right? Yeah, it's an or statement. How could we make the or statement to be true? Yeah, in order for this disjunction to be true, at least one component is true is enough. And the sentence you need to remember for this disjunction is, for a disjunction to be false. Yeah, because we only have one case in which a disjunction is false. For a disjunction to be false, both of the two component statements must be false. Yeah, there's only one case in which a disjunction is false, is when both components are false. In other words, now we have a disjunction P or Q. P or Q is false only when, if and only if, P is false and Q is false. If even just one component is true, then the disjunction is true. Yeah, please take time to write down this on your note. For each type of compound statement, you only need to remember one sentence. This is the sentence you need to understand and memorize for disjunction. In order for a disjunction to be false, both of the two components have to be false. That means in order for P or Q to be false, both P and Q have to be false. If there's at least one piece is true, then the disjunction is true. Yeah, feel why? Yeah, feel why is like that. Because disjunction means P or Q, right? P or Q. So really you just need at least one piece is true. Yeah, at least one piece is true would make the disjunction to be true. Is that clear? Please let me know. Disjunction. Not a lot to remember. Yeah, thank you. Yeah, for each thing, for each compound statement, you only need to remember one sentence. This is the sentence you need to remember for conjunction. And this is the sentence you need to remember for disjunction. Okay, let's practice. This is a disjunction, right? Excuse me. So disjunction, upside down V. The two components of the disjunction is not Q and P. Not Q and P. Yeah, not Q and P. All right. So since this compound statement, this disjunction only contains two simple statements, the first two columns are PQ, T, 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 F, F, T, F, F, the four cases, right? Yeah. Let's complete the table. We do need a not Q because not Q is the first component of the disjunction. The second component is already given, is the first column. Okay. Column 2 and column 3 should have opposite values. Yeah, because Q and not Q, right? So when Q is T, not Q is F. Yeah. So now let's look at this disjunction. The first component is F. Second component is T. Yeah. So is the disjunction T or F? Why? Because they are not both F, right? If they are not both F, then it's going to be T. Yeah, at least one piece is true, and we have that true. So that's that. And the second case, as Q is F, now Q is T. So when the first component is T, column 3 is the first component, column 1 is the second component. You know, my explanation in the video I posted in 1473 is more clear, is clearer, because I'm able to color them and explain, take time to explain. So the first component is true, second component is also true, so this disjunction definitely is true. Case number 3, when Q is T, now Q is F. So now look at here. The disjunction has two component statements. First component, now Q is F. Second component, P is also F. That is the case. The disjunction is going to be F. Yeah, remember the sentence you just wrote on your note. For the disjunction to be false, both two components need to be false. That's the case. When Q is F, now Q is T. Yeah, so this will make this disjunction T. Yeah, because the first component is T. It doesn't matter the second component, the disjunction will not possible to be F, has to be true. All right, any question about this problem? Disjunction. All right, let's continue. Question number 10. So yeah, instead of using PQ, now they are using XY. Same thing. Yeah, lowercase letters are used to represent statements, simple statements. So this column is a disjunction. Column 3 here is a disjunction. The two components preceding the column 3. Both of the two components are true. The disjunction, of course, is true. And its negation is false, right? Yeah. Negation always have opposite value. And disjunction, this disjunction has xt, has the first component true, second component false. So the disjunction is true. And negation is false. Case 3. When the first component is false, second component is true, the disjunction is still true. Yeah, because at least one is true would make the disjunction to be true. And the negation is F. Last case. Last case is when the disjunction is false, because both X and Y are false, right? Yeah. For a disjunction to be false, both of the two components have to be false. So X or Y is, and the negation is true. All right, any questions? Question number 11. Refer to the following statement to answer parts A through part C. You did not take out the trash, but you did not leave the car a mess. Write a statement in symbolic form. Assign letters to simple statements that are not negated. Choose the correct answer below. Yeah. So if we let P be take out the trash, Q is leave the car in mass, then the statement would be not P and not Q. Yeah, but here is a conjunction, right? Conjunction. So let me see how many questions in this 24. And it's already 30 minutes. I'm thinking that you probably could do the following because we already covered the basic. Yeah, we have negation. And negation is very straightforward. If P is true, then Q, then not P is false. Yeah, P and not P always have opposite values. Conjunction, yeah, only need to remember one sentence. And disjunction, only need to remember one sentence. So I'm thinking we are going to skip the rest of the question and go to section 3.4. Is that right, guys? We went over the basics about conjunction and disjunction. Response? Can we go to section 3.4? Okay, awesome. Thank you. Yeah, let's go to close this one. I got kicked out. Okay, it's okay. Very good. So let's go to 3.4. Conditional and biconditional. Yeah, we're going to look at the truth tables for conditional and biconditional. With that covered, you are able to do the homework even just today. You don't have to finish today. I'm just saying we covered the most basic stuff. 3.4. Truth tables for conditional and biconditional. Okay, I'm going to spend time to explain conditional, all right? P implies Q, or if P then Q, is a conditional statement. The two component statements in the conditional play different roles. Yeah, they have different names. P here is called an antecedent. Q here is the consequent. Pretty intuitive because P cause Q, right? Yeah, from P, if P, then Q. So of course, P is the antecedent, Q is the consequent. Should not have any confusion. Yeah. So now I'm going to explain the truth table for P implies Q. P implies Q have two components, two simple statements, P and Q. So the first two columns gonna be P and Q, follow with the four cases. That's bad. Let me rewrite that. 1, 2, 3, 4. Yeah. Okay, we don't have to have this part, and those are extra. The last column would be the target statement, common statement. Okay, so the four cases: case number 1, case number 2, case number 3, case number 4. Do you remember the four cases for P and Q? Yeah, please remember the order is always TT, TF, FT, and FF. Okay? And what we need to remember here is for a conditional to be true. I'm sorry, to be false. for a conditional to be false, the antecedent has to be true, but the consequent must be false. Okay? Yeah. In my video, if you want to know why, please watch my video. It is posted in the QR class, not this class, not essential. Is 1473, the other class videos in the recordings. I have the reason explained. And to make the we don't have time to cover that details, so you watch the video to figure it out. And for the conditional, the sentence that you need to memorize is this sentence, okay? Is this sentence, yeah. So P implies Q has antecedent. This is antecedent. P is the antecedent. Q is a consequence, yeah. For this conditional to be false, we need a antecedent is true, but consequence is false. So that is case number 2, right? Yeah. In all other cases, the conditional are all true. So this is the only case. Case number 2 is the only case a conditional is false. So in order for you to remember that, I have a trick that you can remember as trusted friends forever. Yeah, we like acronyms, right? Yeah, trusted here, trusted, not too much. Use a word, trusted friends forever. Yeah, only trust the friends forever. So trusted is the antecedent, friends is the consequence, and that gives you the false value for the conditional. And all other, they are temporary, okay? If it's not trust the friends, they are temporary. Yeah, for the reason why, please watch my video. And this, now here, we only need to memorize this sentence. For a conditional statement to be false, yeah, there's only one case in which a conditional is false. That is when the antecedent is true, but the consequent is false. Yeah, I'll give you a little bit of time to memorize right now, right here. Only trust the friends forever. If it's not trust the friends, then just temporary. And please respond to me and let me know if that works. Just memorize this sentence. Yeah, to explain, to want to know why you watch my video. Is that clear? For the conclusion about the conditional. Okay, perfect. Yeah, you should write in your note. Yeah, you should include that in your note. Yeah, I think I have in my note as well. Yeah, but you should have your own note. All right, don't forget this sentence for conditional, and we are going to use it. This one, we don't have a compound statement that is always true is called, those are just the concepts. Tautology. Yeah, you figure out your own on your own, is in the guided notes. Conditional statements that are always true are called implications. Yeah, those are also in my video. A common statement that is always false is called a self-contradiction. Those are just simple definitions. Yeah. Yeah, let's skip that. Let's work on the truth table. Yeah, this one. This target statement is a conditional. Okay? Its antecedent is not P. Yeah, the whole thing not P. Not P is the antecedent. Q is the consequence. So The antecedent is here, not P. Q is here. I would add one more column and write a Q right behind, not P. But this doesn't do that. So you have to be aware. Trust the friends forever. Trusted means antecedent, corresponds to antecedent. Friends corresponded to the consequent. Yeah, let's complete the table. Let's do the column 3. Column 3 must be the opposite of column 1, so this is F. Yeah, here, antecedent is F. Consequent is true. Not a trust friends, so temporary. Does that make sense? It is not the case that antecedent is not true. Consequent is not false. So we do not have a trust friends. This conditional is temporary. Is T. Is T. Oops, what happened? You will not receive any credit. You want to continue without checking your answer? No. Check answer. When P is T, not P is Q, not P is F. Okay, so now in this case, we don't have a trust friends either. So it's still temporary, yeah. Antecedent is not a trusted. Even we do have friends for consequent, but we do not have a trusted friends, so it's temporary. And in this case, not P is T. Okay, here we have a trusted, but we don't have a friend, so it's temporary. Only when the antecedent is T and consequent is F, the conditional is F. That's what this sentence is about, right? Yeah, but so far we don't have that case yet. Be aware, the antecedent is column 3. Consequent is column 2. So you have to, do the order, follow that order. Yeah. So when P is F, not P is T. Okay, here we have a trust friends forever. You see that? Antecedent is trusted. T, trusted. Consequent is F, friends. Trusted friends gives us forever. That's the only case that the conditional is false. Please let me know. Oops, where did it go? Yeah, please let me know. Does that make any sense to you? Yeah, again, you want to know why? Watch my video. And at this point, just today in this class, just memorize this sentence. Response, please. Is that understandable by using the logic? Awesome. Awesome. Thank you. Thank you. All right. So now we can continue number 4. Okay. Oh, do I have to always check here? Okay. So, all right. So look at, this is column 1, 2, 3, 4, 5. Yeah, look at the column 5. Column 5, you know what? It's okay that I can copy paste. Yeah, let me try to copy paste. We do that on the OneNote. Otherwise, it's going to be very fast. Yeah, let's complete the table in the OneNote. Here. Now I can take notes, everything, you know. Okay, so I'm going to label column 1, column 2, column 3, column 4, column 5, column 6, right? Yeah, we are going to complete the values in column 5 and column 6. Column 5 is a conditional. Its antecedent is P, so it's 1. Its consequence is not Q. Yes, right here. Here, not Q. Not Q is 4. Yeah, so column 5 has antecedent column 1. Yeah, let me color column 1 as yellow. Column 1 is yellow, antecedent. Yeah, it's antecedent. Column 4 as orange. Yeah, how about let's just always use yellow as antecedent, orange as consequence. Yeah, consequence. All right, so now we are ready to fill in column 5. Yeah, only when we have trusted friends, we got a forever. Only when we have trusted friends, we got a forever. Why? Because we have trusted friends forever. The yellow is antecedent. Antecedent is true. Consequence is false. So the conditional is false. All right? And all other cases, you know, I'm gonna write here. It's better right here. Yeah, all other cases temporary, 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 because they are not trusted friends. This is not trusted friends. This is not trusted friends. This is not trusted friends. So when they are not trusted friends, they are temporary. Yeah, yeah. When I have more thing to write, is better. Yeah. So that is column 5. Yeah. And look at the column 6. The structure of column 6. Column 6 is the negation of column 5. I hope you see it now. Column 6 is the negation of column 5. So just take the opposite of the values. So we have T here, F here, F here, F here. Questions? Yeah, only when the antecedent is true, consequence is false, we have the conditional false. Okay. Yeah, only when P is true, now Q is false. This is a F. All other cases T, 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 and negation has the opposite T, F, F, F. Okay, yeah. So let's find a biconditional. The last basic, here, biconditional. Remember the notation. Biconditional is if and only if and only if, or biconditional statement. All right, yeah. So those two pieces are, the two components are equivalent. Yeah, the sentence we need to remember to about the truth values of a biconditional statement is, for a biconditional to be true, the two component statements must have the same truth values. Yeah, this is the sentence we need to memorize for biconditional. For biconditional. Yeah, very quickly I can make the table for you. 2, 3, 4. P P if and only if Q. Yeah. So this is P, this is Q. 4 cases, T, 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 F, F, T, F, F. So based on the sentence above, for the biconditional to be true, the two components must have the same truth values. Yeah. If they are both true, yes, then the biconditional is true. If they are both false, is the biconditional is true as well? Based on the sentence, it is true as well, right? Yeah, as long as the two component statements have the same values. But when they have different values, and the biconditional is false. All right? Yeah. So please include that in your notes. For a biconditional to be true, the two component statements, plural statements, must have the same truth values. If the two components have the opposite truth values, then the biconditional is false. Let's apply it. Yeah, let's complete this cell first. Now Q is F. Yeah. So now the first component is P. The second component is not Q. They have different values, so the biconditional is false. Biconditional is false. Right? So when Q is F, now Q is T. So this time, column 1, column 3, the two components have the same truth values. So yes, the biconditional is true. This case, when Q is T, now Q is F. And P and now Q now have the same values. So the biconditional is true. Is true here. The last one, when Q is F, now Q is T. But now column 1, column 3 have opposite values, so the biconditional is false. Right? And that is about biconditional. Biconditional is pretty straightforward. Yeah. Just remember, when both components are false, like case 3, when both components are false, the biconditional is true as well. Yeah, we run out of time here. We're gonna keep working on truth tables next week. Today is a Thursday, so we do not meet on Monday because Monday is a holiday. It's in the syllabus. I will meet you on Tuesday. All right, guys, I'll see you on Tuesday. Have a good weekend. Don't forget the homework. Thank you for coming. Okay, bye-bye.